Right, we're going to factorise the following quadratic where x squared plus x minus 90 is the expression we're going to deal with. And so the first thing we need to do is we need to look for two numbers that multiply to give us minus 90 but add to give us x. Let's look at some numbers that multiply to give us minus 90. We could have 1 and 90. One of those would be minus, but obviously they're not going to add to give us x. Another pair of numbers, an obvious pair of numbers, is 9 and 10. You can either have 9 and minus 10 or minus 9 and plus 10. And we can see these two numbers add to give you 1. So if we're going to factorise this, we need x times x to give us x squared, so put those in. And we need two things at times to give us minus 90. If we put in the minus 9 and we put in the plus 10, this is what we get. Now we can always check our answer using FOIL. And FOIL stands for first, outer, inner, last. And the first two things times together gives you x squared. The outer two things give us 10x. The inner two things give us minus 9x. And the last two things give us minus 90. Let's just add those up. The 10x and the minus 9x gives us just 1x. And the minus 90 on the end just stays as it is. And we can see that this equals this. So that is our answer. So that is the right expression. And therefore, our correct answer is this. Right, when factorising, the key thing you must always do first is you must check for any common factors. And straight away, we can see 5 goes into this, 5 goes into this, and 5 goes into this. So we must take that out first. So there's a factor, 5. And that leaves us x squared plus 2x plus 4. And then we look at see if we can factorise this any further. And what we can see is we've got to have two numbers here that multiply to give us 4 if we're going to factorise this any further. So we can, the only two numbers we can look at 1 and 4, and we can look at 2 and 2. This is positive, so these must be positive numbers. Now, if we were to put x and x here, if we put 1 here and 4 here, we can see we'll get a 1x and a 4x, which add up to 5x, which is no good. So let's try 2 and 2. 2x and 2x gives me 4x. That's no good. So actually we cannot factorise this any further. And this is actually as far as we can factorise this expression. Right, we're going to factorise this quadratic, 15x minus 27x minus 6. And as usual, the first thing is to look for any common factors. And we can see 3 goes into this, 3 goes into this, and 3 goes into this. Let's take that out. And so we've got a common factor of 3. And now we've got to factorise this. Let's ignore the 3 for now, or we can just put it there. I'm going to put this into these brackets. Now we need two things that multiply to give us 5x squared. And it's quite clearly 5x and x. There's nothing else you can choose that would multiply to give you that. Now the other numbers in here must multiply to give us minus 2. So we could have minus 1 and 2. We could have 1 and minus 2. And that's pretty much it. So how are we going to put these in? We need to put these in so we can get the minus 9x. So let's try minus 1 here and 2 here. Minus 1 times 5 is minus 5. 2 times x would give us 2x. So therefore that's going to add to give you minus 3x. So that one's no good. So let's try the 2 here and the minus 1 here. So you get minus x. And 10x, 2 times 5x is 10x. That gives us plus 9x. We're getting somewhere closer. That's not quite right. We need a minus. So let's try putting the minus 2 in here and the 1 in here. 1 times x is x. Minus 2 times 5 is minus 10x. Add those two together, you get minus 9x. So this is our correct answer. And let's just check that out by multiplying out. So let's multiply out the brackets first. 5x times 5x is 5x squared. X times 1 is just x. 5x times minus 2x is minus 10x. 1 times minus 2 is minus 2. And let's combine the like terms, the x terms there. X and minus 10x gives us minus 9x. Multiply after out by 3. 3 times 9 is 27x. 3 times minus 2 is minus 6. And it works. Right, we've got 9x x squared plus 9x plus 18 equals 0 as our equation. So we have a quadratic that equals 0. Whenever trying to solve quadratics, you must always make them equal to 0. Okay, because we want to try and use the idea of being able to factorize to solve them. And even if we're not going to use the method of factorize, even if you're going to complete the square or use a quadratic formula, you still need it in this form before you start. So you need everything on the left hand side, which we've got already. Now we're going to use factorization, and we can see that x squared is just x times x. So what things multiply to give you 18? Notice we've got pluses here, so we know everything's going to be positive. So 1 and 18 will work. 2 and 9 can multiply to give you it. And 3 and 6 will multiply to give you 18. What adds up to give us 9? 1 and 18, 2 and 9, 3 or 6? Well, it's obviously 3 and 6. And if we multiply out to check, 3 times x is 3x, 6 times x is 6x, add them together we get the 9x. So we know we got this right. As a check, 3 times 6 is also 18. Yes, it is. So we've now factorized, but we've not solved the quadratic. A lot of people just factorize and think they finished. Actually, you've got to find out what x is. So we have two numbers here. We effectively have one number, x plus 3, times by another number, x plus 6. So we've got the yellow number times the green number must equal 0. So either the yellow number must equal 0 or the green number must equal 0. So either x plus 3 must equal 0 or x plus 6 must equal 0. One of these two things must equal 0. So if that equals 0, okay, then x must equal minus 3. And this equals 0, then x must equal minus 6. So we have two possible answers to this equation. X equals minus 3 or x equals minus 6. And if you want, you can check by putting them back into the equation. So put minus 3 into here, we get 9. Put it into here, we get minus 27. So 9 minus 27 plus 18. Well, 9 plus 18 is 27. Minus 27 is 0. Minus 6. That will give us 36 into here. 9 times minus 6 will give us minus 54. Add 18. 36 add 18 will give us 54. 54 minus 54 is 0. So it works. So this is our final answer.